Okay, moving in the space. It's like a use some name and has been uniformly distributed on this one. Faces it has selected. Okay, now I'll include the force. Insert again force. Now I'll change this geometry selection to the name selection, and whatever the name selection we have created, it will be appearing in this drop down thrust. Okay, then I want to apply with the components. Okay, that is nothing but plus z 60 Newton. Okay, I think including all the phases, it will be 360 Newton. Okay, 60 at each. Okay, other if you apply say 60, then it will be divided into these like uniformly divided on the all the faces. Okay, then I applied force. Now insert. Like whenever you are doing any structural static analysis or dynamic analysis, there should be one what you call support. Okay, otherwise let us consider this body is there already. Okay, 1 minute. If you don't apply any fixed support, whenever you apply force, okay, this body will be moving out. Okay, moving in the space. It's like a rigid body motion. It doesn't have any constraint. Okay, that's why there should be at least one structural load, at least one constraint should be there for solving any analysis. That's why I will add fixed support. Okay, fixed support. I will use these whatever faces are touching to the ground. I applied fixed support onto this one. Okay, from beginning I will again come back. Okay, first what I did, I imported a geometry, and after that geometry I have applied the aluminum material properties, that one. Okay, then I have gone with the automatic connections whatever ANSYS has created, since it is linear analysis. Then I have created a name selection. Okay, name selection for the faces to apply the thrust forces, to apply the for thrust force coming from the motor to apply. And after that I have done the mesh. Okay, with the body sizing as 4 mm. Okay, and I checked the quality of the mesh, and after that I went for the force. I applied payload force, that is a like acting downwards, then force of the thrust force, this is, and I have given on fixed support. Now I want to consider the self weight of the drone also. Insert standard earth gravity. Okay, it has taken already for the all bodies, it will be taking. Okay, I have taken all these things. Okay, now I want to do the analysis. And these you can see a number of cores you can mention as 6 in like my software and computer is capable of doing that one. I am doing usually like it will be 4 cores only. Okay, don't change that one. And like whenever something like these windows will go away like that happens, then you can in the home you can use the option reset layout. Okay, and these are some of the whatever the selection panel, you will be getting used to this one. Okay, then I have done the analysis. Then let me solve this one. You can see the progress at the bottom, and whenever you click on the solution information, there is a solver output. Okay, that file will be writing here from the beginning. Okay, what are the elements, what is the unit system, what are the material properties you have, which is the version of the software. Okay, everything where the file has been saved, input file name, output file name, you can see this is a dat file, this is the output file. Okay, sol.out, and everything will be written here. You can check what is the units. Okay, length, mass, time, temperature, force, heat, what are the units used. Okay, again you can check everything here. It has been solved now. Okay, I'll click on the solution. Okay, now First, insert, deformation, total, insert, stress, equivalent measures. Let me evaluate these two. After that, I'll show you one by one. Okay, now you can see this is a total deformation. Okay, this is total deformation. I will 1 minute result. Okay, this is without elements how it will be looking. Okay, and this is the maximum value, that is 0.93 mm. Okay, whenever I play the animation, how it will be deforming, it will be showing. Okay, this is, you always be cautious, you have to check the scale. Here you can see it is 57 times magnified. Okay, this is auto scale. For your effect it is showing like that. Okay, then you can change it to the true scale also. Okay, this is the true scale. This is the true scale, how it will be behaving. And this is the auto scale, where it will be showing like how this body will be 57 times it has been magnified. Okay, you have to take these things. Okay, this is the maximum and this is the average, and whenever you go down here, like minimum and maximum values it will be showing, and minimum occurs on which body and maximum occurs in which body. Okay, it will show that one also. If you click on these, whatever the check boxes are there, those will be parameterized. Parametric study I was mentioning, right? Okay, that one on. Okay, then now I'll go for the stresses. Okay, okay, you can check for the stresses. Okay, then in the result there is a probe option. Okay, whenever you use the probe, like on wherever you are hovering on the surface, okay, it will give you the whatever the values are deformation or stress. If I click stress here, again go here. Okay, it is 31 megapascal. Okay, and whatever the stress is coming on the body, you can check here. And if you click on the maximum, where is the stress maximum, it will show that part. Like that it will be showing. Okay, if you go like when you're using the probe, if you click on that one, it will show you the node number, that is 295,295,104, and what is the value of that one. This one, like that. Okay, it will be, you can see it will be registered here in the below. I will click here. I'll click here. I'll go to total deformation. Then again I'll go to probe. I'll click here. Okay, everything location of YZ and what is the value, everything will be coming. Node ID. Okay, and to which part it is associated, everything will be coming. To part name, everything. Okay, this is regarding the structural analysis. Okay, this is for the complete body. I have post processed. Now I will go with individual bodies. Okay, deformation, I'll go with directional. Then all bodies can be changed. Now I'll go with this arms I am concerned about. Okay, I will click on this one, and I'm concerned about the Z direction deformation. I'll change it to Z. Okay, evaluate all results. Now you can see on the one body it is showing. Okay, maximum it is happening at the to like 0.6455 in the Z direction. You can do like this. Okay, you can individually select the parts for the bodies, faces, edges, vertex, wherever possible. You can evaluate all the results also. Okay, this is regarding the structural analysis. Okay, and these are strains, different kinds of stresses available here. Okay, deformation, total and directional. Fatigue tool is also available, contact tool. Okay, stress tool, maximum equivalent stress. So these are nothing but failure theories. Okay, and this is regarding the structural analysis of the drone. Now let me go for the another one, dynamic analysis. That is, this is regarding the modal analysis. I want to find the natural frequencies of this. Okay, natural frequencies of this drone I want to find out, like hexacopter. Okay, this whatever the setup will be remaining same till the meshing. Okay, since model analysis, I think you can remember, right? 1 minute. Okay, model analysis comes under free vibration. There will be no external load. Okay, that's why. Okay, here no structural loads, only fixed support will be there. Okay, then we can do the modal analysis. What are the natural frequency, what are the mode shapes and mode participation factor, we can check that one. On the same setup I will be doing that one. Okay, now you can click here, insert, or there is option analysis. Okay, I will use the model here. Okay, model in the analysis, that whatever the up to name selection and mesh, everything is same only. Okay, now in the setup, I want to add only one fixed support. Okay, this is the only thing required for the model analysis. Even the fixed support is also not required. Okay, here I am doing the fixed model analysis, fixed. Okay, there will be conditions where it will be using free model analysis, which means fixed support is not used. That can also be done here. Okay, and analysis settings, you can see maximum modes to find. It has 6. Okay, I will change it to some 15 modes you need to find. Okay, then I'll click here and solve. Okay, it has carried out the model analysis. You can see at the right bottom corners. Okay, it has given the 15 frequencies whatever I requested. It starts 23.768, 31.421. Okay, what is the significance of these frequencies? I think you might have studied in the vibrations, right? Okay, whenever whatever the force or loads you are giving with the excited frequency equal to 23.768, then the resonance happens. Then the body feels. Okay, that's why these are important. I will right click, create mode shape results. Okay, I want to see what are the different modes for the different frequencies. Okay, evaluate all results. Okay, now you can see from for a particular frequency how body will be vibrating. Okay, if you match frequency 23.768, your body will be resonating like this. The next one is that is 31.421. If you, it's like a twisting mode. I think you might have studied the mode steps of the cantilever beam, 1, 2, 3, mode 1, mode 2, mode 3, like that. These are the things for the whole assembly. This is due to the blades, same different blades in different direction. This is the mode shape, whatever it is showing. But these are the natural frequencies. Okay, when you click on solution information, participation factor summary, you can click on this one. Okay, now we can come back, come down. Okay, you can see this, what are the participation factor I was mentioning, like by effective mass to the total mass. Okay, you can see here X, Y, Z direction. Whatever the frequency, like 15 modes we have extracted. Okay, including all. Okay, from 1 to 15, whatever the frequencies are there. Okay, 20% of the mass is vibrated in the X direction, 72% vibrated in the Y direction, and Z direction it is really low. Okay, these are the some of the significance of the participation factor, which means, okay, you can see for a particular frequency. Okay, 23.768. If you see this one, x direction is really low, z direction is really low, but when you compare the direction, it is really good compared to other two, which means whenever you are applying force at 23.768 hertz, it should be vibrated in pi direction, then only resonance happens. Okay, this is what it signifies. Same like for the other frequencies also. Now you can check here, this is 0509. Okay, this one is also for the y direction, third is for the x direction. Like that it will identify. When you click on the solution output, participation factor summary will be coming out. Okay, you can see like these kind of things. This is regarding the structural and model analysis of the hexacopter. Okay, I didn't do any complex thing, just I demonstrated you the how to do the optimal study on this one. Okay, this is simple structure. I use the aluminum geometry and use the default connections, that is bonded connections linear analysis I am doing, and used mesh local controls with body sizing as 4 mm. It has given me good meshing, and after that I have used some of the name selection for the application of the thrust force and as well as for the payload force, and I have considered the mass of the drone or hexacopter using the standard earth gravity, and I have fixed the bottom part of the hexacopter to avoid the rigid body motion. Okay, then after that I have solved the problem, and using that one, like from the post processing results, you can see these are the some results regarding deformation, stress and directional deformation. Okay, these are the some of the things. And modal analysis is nothing but we need to find the natural frequency and mode shapes of the body. Okay, whenever natural frequency is nothing but after giving initial displacement, at which frequency body will be vibrating, we will be calling as a natural frequency. And natural frequency is nothing but root k by m. Okay, natural frequency is a inherent property of the it is like it depends on the body's properties, not on the external force. Okay, as you can see, root k by m is nothing but k is the stiffness, m is the mass. Okay, k stiffness depends on the Young's modulus, mass depends on the density. Okay, that's why natural frequency is nothing but only depends on the properties of the body, not from the external force. That's why external force we are not considering here. Okay, and we have given the fixed support and we have extracted the natural frequencies. Okay, as mentioned in the analysis settings, we have considered the 15 natural frequencies, and for each natural frequency we have seen the how the mode shape is there, how the body will be vibrating. Okay, this is regarding the demonstration part of it. And now I will go with whatever the Shahjad already carried out. Okay, I think you might have known this one, but let me go fluent. Okay, I will be carrying the pressure data. Okay, whatever the pressure coming on the all the external faces. Okay, it will be stored in the CFD files. Okay, those files I will be importing into the mechanical and doing the structural analysis same way as I have done for the this whatever the drone. Okay, let me go for the static structural, drag and drop on this one. Geometry I don't need. Just I'll go to geometry. Okay, I think you will be knowing for structures we will be considering the actual geometry. Okay, where all the bodies are there, but fluent we will be considering for the external flows, we will be considering the external outside flow domain, whatever is there. That's why we need to have some of the like modification in the geometry. We can do that one here. Okay, extra. You can see here that the actual body has been suppressed when we are carrying out analysis for the CFD. Okay, I want to turn on that one, activate for the physics. Okay, then I'll go back to workbench. Okay, now I'll go to geometry. Okay, I will suppress these two. I don't want them. Okay, only body I want here. This one. I will change this properties to aluminum. Since it is a single geometry, there is no need of connections. Okay, it has been suppressed now. Let me see first how it will be meshing. Okay, by default it has meshed. I want to give some of the sizing. Okay, I'll go with 10 mm. Yeah, it has meshed. Let me change it to the 5 mm also. Okay, let it be as 10 mm. Okay, it has been meshed with 10 mm. Now I want to import the load from the CFD. Okay, insert imported load option will be there. Insert. I want to import the pressure. You can either import the temperature or the pressure. Pressure I am importing. Okay, geometry it is asking. Okay, I'll have to select all the faces now. Select on this one. Select all. Except this fan faces. Everything is there. I will remove these faces. Apply. And in the CFD surface, you will be defining like this name. What is the CFD surface? Okay, you can see here in the CFD surface, there are option. Okay, this is nothing but drone surface only. Okay, I will insert in another one. Pressure, geometry will be these, whatever the faces I have already used. Just now I'll unselect it. This is the fan surface named in the CFD. Okay, import those loads one by one. Okay, now you can see that it has imported the pressure on the surface. Let me import this one also. Okay, it has imported the pressure on the fan part of it. Okay, since it is a structural analysis, you need to have at least one constraint. I am giving fixed support to these phases of the rollers. Okay, then I think we are done now. Okay, we can solve now. Okay, it has solved. Now I want to see what is the deformation. Okay, what is the pressure, like the stress coming on the body. Now you can check this. Okay, this is like magnified scale, that like this. I'll go with true scale. Okay, this is the behavior of a, and
तुम बहुत 20 22 25 पे लगा रहे हो। देख लो अपने हिसाब से, दुकान वाले से बात कर लो यार। दुकान वाले से क्या बात करनी है? मेरे को भी कहा पता होता तो बता देता। तासे भी तेरे साथ में। तासों का तो तासों से पूछ लो। तो पापा मैं क्या बताऊंगा यार, मैं खुद 2 साल से नहीं खरीद रहा हूँ। एक बात तो समझ में नहीं आता। वन प्लस का फोन कभी अपन ने चला ही नहीं है, ओप्पो का फोन चला ही नहीं है, वीवो और रेडमी का तो चला ही नहीं। रेडमी नोट 10 आना ही बंद हो गया। 4G सेट है ना। रेडमी नोट 10 है। अच्छा ये 5G है। दोनों 5G।
Is the stress, it is really low. This is the one-way FSA, like we will be taking the data from fluent, that is pressure data, and mapping onto the mechanical. This is the one regarding the one-way FSA. This is regarding the demonstration, and I have some of the best practices to cover. Let me cover them. After that, we can have the question answer session. Okay, these are some of the best practices for FEA. First one is mesh convergence. Second one, mesh quality, submodeling, types of analysis, material modeling, contact tool, averaged and unaveraged results, adaptive convergence, and parametric study. Okay, first one, mesh convergence. Okay, you might be having some question whenever you are doing any analysis. You will be asking yourself like, what will be the optimum size of the element? Okay, how to decide that one? Okay, and what is the optimum size of the element whenever doing any analysis? Okay, there is a term called mesh convergence. Okay, you can in this 1 minute you can see now. Okay, element size is 10 mm.
मेरे से
Okay, it
पूछ
has
के अब
produced
कोई काम
60
मत करना
MPa
तुम।
stress.
मेरे
Okay, after that
नहीं
I
यार,
change
सर
it to
तुम
the
फोन में
element
नेट है,
MPa,
तुम कर लो सर।
element
अरे
stress,
हमें मत
the
करो
element
तो
size to the 8 mm. Okay, then you can see now
वन प्लस
the
में
stress has been changed to 62 MPa. Okay, after that I changed the element size to 6 mm. It has changed to the 63 MPa. Okay, now I change the element size to 4 mm, then it is around 63.4. Okay, when I change to the element size to 2 mm, it is 63.6. Okay, you can see here there is a change, like drastic change from one result to the other result. But when you are keep on changing the element size, okay, that result will be becoming the constant. Okay, this we call as mesh independent solution. Okay, whenever we are doing any analysis, we have to establish mesh independent solution. Mesh independent is nothing but whatever the element size are you are changing, that result should not vary. Okay, that element size you need to achieve, that we call as the optimum size. Okay, here we can call as that results will be like this only, this line will be flat, we will be calling as mesh convergence have been achieved. Okay, this is we call as a mesh convergence. This one, okay, you need to go like you need to always to achieve mesh convergence. So there are 2 to 3 methods are there in the upcoming slides. I can show you what you mean by mesh convergence. I am explaining. You have to extract the results which is independent of mesh size. Okay, even though you are changing any mesh size, it shouldn't change, result shouldn't change. Okay, that's we call as a mesh convergence. Okay, next one, mesh convergence, mesh quality. Okay, whenever you did some analysis, okay, that is you have meshed some body. After that, if you go to the same, that is mesh metric. In the mesh metric, you check on the element quality. Okay, these graphs will be coming. It will be showing in the range of 0 to 1. Okay, it start with 0, it go with 1 here. Okay, then what you mean by 0, what you mean by 1? 0 is nothing, 1 is nothing but ideal shape of the element. If you consider any hexaedral or tetrahedral, what is the ideal shape before meshing? Okay, if you what is the, if the tower is indicating, whatever the graph is indicating, that is 1, then all the elements are in the like ideal shape. If it is saving as 0, then all the elements are like distorted, completely distorted. That is not acceptable. Okay, from this graph you can go there, and if you click on these graphs, okay, as you can see, these are pink color, right? When you click on these, already they are clicked, that's why these elements has been shown here. Okay, these are having the quality, really poor quality, these elements. Okay, that has been shown here. Okay, and type of elements it will be showing here. You can see tet 10 you are able, type of elements and element quality can be checked in the mesh quality can be checked in the mesh metric. Okay, you always remember this one. Whenever you are doing any analysis, if you've done the meshing, then you go to the mesh metric and check the quality. This is really important. And be make sure that all the elements should fall above point 0.2. Point 0.2 above is acceptable. Point 0.2 and above is acceptable. Please make sure that in some cases. Okay, next one is submodeling. Okay, this is one other kind of what we call meshing technique. Okay, you are doing any analysis. If you go with whatever element quality I have explained in the last slide, okay, element what you call element count may be getting really high. Okay, then what happens? This memory required to solve the problem is really high, and time required to solve the problem is also high. Okay, in those cases, your computer might not be efficient to solve those kind of problems. Okay, then what you can do? This is the another option, submodeling. Wherever the your interest region is there, region of interest, there you can have the like what you call fine mesh. Other than that places, you can have the coarse mesh. Okay, that can be achieved in this one. Okay, this submodeling what we call, you can see here. First,
Hello.
this is a geometry, and the geometry you do the whatever this is there. Okay,
घर
this is
से
the
देख के
critical
नहीं गया
area.
था
Whatever here it has shown, this is the critical area. This is that one. Okay, you do the complete analysis with whatever the coarse mesh is there. You do that one. After that, what you
मॉडल का
need to
नाम
do?
क्या है
You need to slice this geometry. Whatever the region of interest is there, you need to take that one. Okay, you need to take that one, you need to insert here in this one. Okay, this is the complete geometry. Okay, this geometry is different. This is like whatever the region of interest is there, that part only you need to take here. You took that one. After that, this solution needs to be set up to this one. Okay, which means wherever you cut, right, it has been cut in these areas. Okay, these cut boundary constraints can be mapped onto the these whatever the new geometry is there. Okay, with the finer mesh, it has been meshed with finer quality, and whatever the boundary conditions are there. Okay, this from the solution it has been mapped onto the this using the cut boundary constraint what we call. Okay, and then you can solve and you can evaluate what is the stresses coming here, and what those things you can be evaluated. Submodeling is nothing but complete body. You do the analysis and take the sum of the region of interest. Okay, isolate that from the complete geometry and take it to the another mechanical window. In that one, you assign the in that one you need to assign the like cut boundary constraint. That is imported one. Okay, imported means it will be coming from the solution of the that whatever the analysis you have done before. Okay, these are some of the meshing best practices. Okay, usually most of them will be preferring going with hexahedral elements. There is a reason for that one, because 12 tetrahedral elements may form into the one hexahedral elements. Okay, you can imagine now. Okay, 12 tetrahedral elements is equal to the one hexahedral element, which means mesh count is less and element count is less, and the this node count is less, which means okay, results will be really faster. Okay, you don't need more memory also.
So
Okay,
guys,
faster
मेरे पास
solution
है
with better accuracy.
OnePlus Nord
Hexadral
C3
will be having
Lite और मैंने
always
यहाँ पर
better
हाल ही में
accuracy
परचेज
compared to
किया है।
that one.
तो बात करेंगे इसके हम कुछ
Okay,
कॉन्स
patch,
की, तो यहाँ पर क्या क्या चीजें अच्छी नहीं
but
लगी हैं।
hexadral
पहली
elements will
बात इसका
be
यहाँ पर फुल एडी
hexadral
सपोर्ट
meshing will be
अवेलेबल है,
possible on the
मेमोरी हो या फिर
whatever the
आप
structures
वीडियो
like
डाउनलोड करके
order
चलाएंगे
geometry
तो
what we
वो
call.
4 GB
It is possible on that one. Okay, if it is body having some complexity and curvature and these kind of things, it is really difficult to achieve that one. Okay, even though you forcefully achieve that one, but hexadral element quality will be really poor, which might result to may lead to the what you call poor results accuracy. Okay, otherwise in those cases I what I prefer is patch confirming method, that is tetrahedral elements. Tetrahedral elements are like uniformal elements, those can be used for meshing of any complex geometry, any kind of geometry. Okay, and you can achieve the better quality compared to the hexagonal mesh with poor quality. You can achieve the good quality with the tetrahedral mesh, and you can go for the results, and you will be having the better accuracy compared to the hexagonal elements. Okay, and whenever you click on the mesh, there will be option go, like it will show you the sweepable bodies. Okay, in those cases you can use the sweep method, it will get you the hexa elements. Okay, and by default ANSYS will go through the quadratic elements can be changed to the linear by user. Okay, and by default it will try to mesh with hexadral elements. If it's not possible, it will go with the tet elements. Okay, global and local mesh controls really important for the user, you to achieve the like global and as well as local at a particular place to achieve the fine quality of meshing. Okay, next one regarding the types of analysis, which one to choose. Okay, it depends. Here you can see here, okay, there are two graphs. One is non-linearity, one is problem time magnitude. Okay, problem time magnitude, you can see like if it is falls above 1 second to the 1 year, 1 second to the 1 year, that is we will be calling as quasi static process. Okay, and static and dynamic analysis, 1 second, 10 second, 1 year, this is regarding the creep modeling is rate dependent plasticity, rate dependent strain hardening, everything can be modeled in the static part. We call it as the implicit methods. Here implicit method effort required to put get the results is really high, because it will be using unknowns, whatever the time magnitude, like whatever the output from the next step, it will be using. Okay, so the iterative method is used in this one. The next, now non-linearity is little bit low here, but there is high non-linearity, and problem of time magnitude is really low. You can see 0. 0.1, 0.01, 0.001, 0.001 drop, impact, ballistic detonation, blast, hypervelocity impact. Okay, these kind of comes under the explicit methods. Okay, where high non-linearity and time magnitude is really low. In those drop, impact, crash, blast, detonation comes under explicit method. These are nothing but implicit methods. And next one is material modeling. Okay, and material modeling, like you can see here, for hyperelastic there are neo-Hookean, Mooney-Rivlin, polynomial, Yo, Ogden, response surface. Okay, response function, everything is available. Okay, different kind of materials, isotropic, orthotropic, that is complex, the composite materials, hyperelastic material, plasticity material, creeps, and viscoelastic, plastics, everything can be modeled. Plasticity, creep, geomechanical material, composite, everything material data is there, and material modeling can be done this one, and the same material will be used to the analysis and to solve the problem. Okay, so solve, let us you assume that you have given one body in the geometry, and the material, how to decide that one. Is it a hyper elastic? Is it a plastic material? Is it a viscoelastic material? Okay, for that one you need to always have to like what define the material properties. Okay, depends on the some of the material modeling available also, you can use them and do the material modeling part. Okay, next one, contact tool. Okay, you can see this is a contact tool. Okay, in contact tool, like each contact will be, what is the initial status, is it closed, is it inactive, is it large open, far open. Okay, this red kind of status is not acceptable. Whenever you are doing analysis without checking the contact tool, if you do the analysis then the analysis fails, then you can again have to come back and check that one. The best practice is always go with the at the beginning only contact tool, check if there are any like problem with the contacts. Okay, like gaps, penetration, pinball. Okay, everything you can check in the contact tool. This is the best practice to always going before analysis only you have to do. Okay, then you will be saying like what is the mesh, best mesh, how you say this mesh, whatever you have achieved it is good. Okay, but you can see here there are equivalent stress 1 and 2. Okay, display option, there is a averaged and unaveraged. Okay, averaged and unaveraged means, like average means, okay, let us consider one element is there, that element is having four nodes. At each node it is having different kind of at each node it is having different kind of results. Okay, let us consider it as some 20 megapascal, 10 megapascal, 5 megapascal, 20 megapascal. Okay, average means, okay, it will average out the all the results from the nodes. Okay, it will give you 20 plus 20 plus 5 plus 10. Okay, divided by 4, whatever the result it is coming, it will give you that one. Okay, unaveraged means whenever you are checking with any node, okay, highest value it will be giving. Okay, then what you have to know do, you have to check what is the value, maximum value. Here it is for averaged and average, and what is the variation. If the variation is within the 10% for any assembly, you will be saying yes, whatever the mesh quality you have achieved is really good. If the variation is really high, then again you go back and mesh the geometry and do give the sum of the controls and achieve the whatever the quality you wanted, then again come back to here and check the average and unaverage results. Okay, this is the difference between average and unaverage result. This is really useful. Okay. The next one is adaptive convergence. Okay, you can see here in the your post processing total deformation. Okay, there is an option convergence. Okay, this convergence if you add automatically whatever I discussed in the first slide. Okay, and then you need to variation. You need to have the allowable change. If the 5% variation from the last iteration is allowable, then you can mention like 5%, 2%, 10%. Okay, you can mention that values, and it will directly do the convergence study. Okay, it will do the conversion study. You can see it will give you the number of nodes. Okay, and now after number of nodes, what is the percentage change? Okay, what is the results? Here total deformation results are also here. It's like a table. You can see here, this is the graph. A conversion study, it can be directly done for the static analysis. Okay, not for the dynamic, non-linear or dynamic, only for the static linear analysis. The next one is parametric study, and you already know, like I explained you, my input parameters may be material, mesh, geometry, loads, boundary conditions, point mass. Output parameters may be stress and strain deformation. Okay, you can see here, there is these are input parameters, these are output parameters. Okay, output parameter is nothing but equivalent stress. Okay, input parameter is, this is revolve, that is geometry component. These are everything is regarding geometry, and this is Newton means these are forces. These two are forces, and movement, this is Newton per millimeter. It is, they are varying. We can see here they are, okay, this is design point 1, design point 2, design point 3. They are giving different values as input. Okay, and they software will be calculating the output for that one. Okay, these are the output for that one, different combinations and different, this parametric study what we call. Okay, yeah. uh, I think I have completed with whatever the slides I have and with demonstration I have.
पेपर में
Okay, please, if you
आपके
have
वैसे ही
any
और ये भी देखेंगे
if you
कि
have
ये
any question,
पेपर
please
यहाँ पर
feel
है
free
तो
to
अच्छी
ask
बात है
me.
कि कुछ ब्रांड स्टाइल करती है एनीवेज ये चीज यहाँ पर आपको ओप्पो की फोटो बहुत अच्छी
Yes,
मिलेगी
you can
फोन देखने
unmute
में
yourself
काफी
and ask the
खूबसूरत है
question.
जो कलर हमारे पास है ये है बोल्ड गोल्ड और इसके कैमरा सेंसर्स देखेंगे तो काफी उन्होंने अलग तरीके का लुक दिया है मोटा मोटा यहाँ पर
Yeah,
दिया है
Vinod,
और
you
नीचे
can
की तरफ
ask now.
डेकोरेटिव आपको रिंग यहाँ पर मिलता है मतलब पूरा जो लेआउट है कैमरे के साथ जो उन्होंने ये जो टेक्सचर यहाँ पर जो इफेक्ट्स दिया है ये बहुत मुझे अच्छा लग रहा है और नीचे 3D कर्व आपको बैक मिलता है ये
Hello.
आपको पॉलीकार्बोनेट
Yeah,
बट
Vinod,
थोड़ा
you
सा
can
हार्ड
ask.
लगता है और फ्रेम्स भी आपको पॉलीकार्बोनेट मिलते हैं स्लिम फ्रेम है 8.2 mm की थिकनेस 192 ग्राम्स का तो ये तो आप ओप्पो के लोगों से देखेंगे लेकिन ओवरऑल जो लुक एंड फील है वो काफी ज्यादा प्रीमियम मिलेगा लेकिन
Yeah, definitely. You will be getting the recorded version of this session.
Hello, sir.
Yes, yes.
हेलो
Sir, how many
देख रहा
kind
हूँ
of like simulations and reports we have to show for Aerothon, like CFD and FEA and vibration and
Yeah, these three CFD. Okay, after that FEA for the static analysis. Okay, then for the vibrational analysis, you need to go for the dynamic analysis. Okay, that is random vibration and the harmonic and the modal analysis. These three comes under dynamic part of it. And whatever I have shown you, that is static analysis.
हाई एंड रिफ्रेशन दे दिया है जो
sir,
कि
please
डिस्प्ले
pardon.
की स्मूथनेस को काफी अच्छी कर देता है और साथ ही साथ कंट्रोल सेंटर में छोटा इंचिंग आपको कम
Whatever
मिलती
you
है
have
मतलब
said, CFD,
91.4% आपको
Yes, sir.
static and
रिफ्रेशन मिलता है
dynamic.
तो जब आप
Okay,
वीडियोस
these
वगैरह
three
देखते
are
हैं
the
गेम खेलते हैं तो
things you
बेल्स
need to
आपको इतना
demonstrate
वाइड
that
नहीं
one.
करेंगे और साथ में
Okay,
आपको
sir.
उसमें
Thank you.
वाइड बैंड एलिमेंट
Static is
सर्टिफिकेशन
whatever I
मिलता है
have carried
बैंडविड्थ
out, right?
एब्जॉर्बर हमने चेक किया
Okay,
तो हमने
dynamic
एचडी
means
स्ट्रीम
whatever modal
1080
analysis,
बहुत सारे शोज में
harmonic
कंपेटेबल होते हैं
analysis, and
और साथ
random
ही
vibration
साथ इसमें
analysis.
आपको
These three comes
600
under that
निट्स की
one.
आपको पीक ब्राइटनेस मिलती है
Thank you, sir.
680 निट्स का
Sure.
मतलब ये होता है कि अगर आप आउटडोर में जाते हैं तो यहाँ पर विजिबिलिटी हमें
hello
देखा तो
sir.
अच्छी लगेगी
Yes, sir.
So I have one doubt, sir. In CFD, in order to check if our solution is correct or not, we look into convergence, if the solution is converging or not. In the static structural case, how can we verify if our solution is right or wrong? So for example, do we have any sort of some sort of graph to see if the solution is converging or like solution is right or not?
Yeah, for linear analysis, there is no graphs. Okay, this is linear analysis. Okay, whenever you do the nonlinear analysis, this 1 minute. Okay, here those controls will be coming. Let me 1 minute. Let me share my screen. Open one project. You will get to know. You are able to see my screen? Hello?
Sir, so I'm audible. There's no screen visible. It's only showing blank screen.
It is
Hello.
showing blanks. Okay, 1 minute. Can you check now?
Yes, sir.
Is it
Not
visible?
visible.
Yeah. Okay, you are able to see this graph, right?
Yes, sir.
Yeah. Okay, this graph, whatever is there, this will be applicable for the nonlinear analysis. For linear analysis, we won't be having any residuals to be calculated. It's a simple whatever Ku is equal to F is there, right? In that one. Okay, in that Ku is equal to F means K stiffness will be always constant. For a whatever the load you are applying, stiffness will be always constant. Okay, U and F is the applied force. You will be directly calculated. There won't be any residuals. Okay, it's a direct solution method. There is no iterative
कैमरा
process in
कैमरा
that
फिर भी
one.
ओप्पो
There
का
is no
सही है
residuals. But when you go for
वन
the
प्लस का
nonlinear
सही है
analysis, okay, in the nonlinear analysis
लेना
there
ही
will
है
be
तो वन प्लस
residuals,
ले यार बाकी
which
मेरे
means
हिसाब से कोई
stiffness
इसमें
at
सीन नहीं है
each
भाई
step
यार
it will be changing. You have to evaluate that stiffness. You have to check that what is the stiffness at this stage. For that one, these whatever the force convergence graph is there, it will be helpful. Force convergence and displacement convergence. Okay, this is the residual force, whatever the criteria we are setting, it will be automatically it will be setting, and this is the whatever this is the convergence graph. Okay, if it is false below this one, we will be saying as converged. Okay, it will be only coming under non-linear part of it, not for the linear analysis.
Okay, sir.
Yeah, sure.
Thank you, sir.
Okay, thank you.
So, do we have to define the force before the machine or after the machine?
I'm
How
not
we
able to
select
hear
it,
you. It's really low.
sir? So now,
Yeah, your voice is really low,
are you
Karandip.
hearing me now?
Yes, yes.
Sir, I'm asking when we have to define the force before meshing or while after the meshing, and how you selected those like named faces. I didn't get that part.
Name phases. So 1 minute. This one you are telling, right? Name selection.
Yes.
Okay, name selection is okay. Let me go here. I will show on the other body now. Okay, this whatever the geometry is there, right? This whatever the face I have selected, this face, this face, this face, this face, this face are having same cross section area. Okay, manually selecting them is it is really difficult, right? Like 6 times you need to click. Just I click here. Okay, insert. Just after click right clicking here. Okay, name selection. Okay, create name selection. After that, there is a second option. Apply geometry items of same size. Okay, and same type. Use that one. Okay, it has selected the selection. Now you can see there are 12 faces areas.
Okay.
Okay, this is the always it will be useful. There will be huge assembly in which there will be some bolts which will be having 3 mm diameter. Okay, there will be so huge 100 bolts individually going into the assembly and hiding some bodies and selecting individual bolts. It is really difficult, right? If you are applying some bolt pretension, directly you select one of the faces of the bolt. Okay, then create the name selection with the same size. Okay, same if it is having same area, then it will automatically select, and then you can see here and verify that one.
Okay. And so the force
Okay,
will define after the meshing.
yes.
Okay.
This is like one by one, like till meshing and name selection it is pre-processing. Okay, force comes under processing part of it. After that
Okay, sir.
solution it will be post processing.
Thank you, sir.
Yes. Yeah, please unmute and ask.
Hello, sir.
Yes.
Sir, can you briefly explain the difference between linear and nonlinear simulation?
Linear and non-linear simulation. 1 minute.
Yes, sir.
Okay, in the linear, you can see force and displacement relationship will be linear because stiffness will be constant. Okay, stiffness won't change. Whatever the load step, whatever the step you are applying, okay, stiffness will be same. Then equation you can imagine Ku is equal to F, right? Okay, K is constant always. Then U and F will be if there is a straight line relations to be established, then U and F should be linear, right? Okay, whatever the U value varies, then that amount should be varied by the F also. Okay, this is linear analysis where you can see here stress strain curve also it will be linear only. There won't be any plasticity part will be considered. 1 minute. Okay, it's okay. There won't be any plasticity part will be considered. It's like a linear one. But in actual case, what happens? Okay, it will go like this. It will go like, and it will fail somewhere like this. There is a plasticity is happening. Okay, this plasticity we won't be considering the linear analysis. Only stress strain. Whatever the stress it is like strain, it will give you like if you 800 megapascal, 1000 megapascal to 1200 megapascal like that it will give you. But when you consider the plasticity, like it won't cross the yield strength. Okay, and it will give you the permanent plastic deformation in the non-linear analysis. But linear analysis it won't be giving that part also. And okay, in the nonlinear analysis, you can see here that force and displacement relationship doesn't hold same. Okay, first you consider on the fishing pole rod is there, right? Okay, fishing pole